Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Hakim bin Zaidi, and my group member is Faris Farhan and Muhammad Aiman. Today we're going to represent about 3D texture mapping. Texture mapping is a technique to improve the appearance of an object. It is used to provide color detail to the object surface, increase the realism, and improve the quality by wrapping an image around the 3D model. For example, a wooden texture can make a flat polygon appear to be made of wood. Here are the examples how the texture is wrapped around the 3D model, which produce a realistic 3D model. Type of texture map. Other than normal texture that give color and pattern to the 3D model, there are other types of texture that can give further detailing to the model, such as bump map, displacement maps, transparency map, specular map, and etc. Bump map. It gives a bumpy detail to the object surfaces, made out of 2D grayscale map that modify shading of geometry. Here are examples. A basic 3D sphere plus the texture of the bump map will give a bumpy surfaces to the 3D model. Displacement map. Similar to bump map, but store height information and modify geometry when rendering. Bump map do not have the height information, which only used for low polygon, while displacement map is for high polygon with a better detail with the height information, which change the vertices of the 3D model. Transparency map. Make an object surface transparent or opaque according to an image map. Here are the example where the 3D model is hide the 3D model behind, but when we apply the texture here, it will become transparency where the 3D model behind can be seen. Specular map. Give a reflective detail to the 3D model according to the light source. Here the example, texture plus the 3D model give a reflective shiny surfaces. Method. Method will be explained by Aiman.
Thank you, Luqman. Now it is my turn. My name is Muhammad Aiman Zaidi, and I'm gonna explain what is the method of 3D texture mapping. 3D texture mapping has several methods that have been used, which is some of it was a point sampling, map map, and a sum area tables. And now let's jump into the first method of texture mapping, which is a point sampling. Point sampling is actually using a texel color for determining pixel color. And what is texel actually? Texel is a short form from texture element. While we have a pixel that represents in form of images 2D version, we had a texel that represents a 3D objects. A texel is like a container that can hold multiple pixels or part of pixel. Texel whose center lies nearest to the projected pixel center will use the color of the texel as pixel color. And now let me put a little more detail about what the last point means too. Okay, as we can see here, there is an image with one kind of shape and two different kind of color. And if you look upon to our scenario, which is here, this part of pixel is actually had some green region inside here. So to determine what the color inside the pixel must be used, it must depend on the center of itself. So if the center was in yellow color, so it means that this pixel gonna turn into the yellow color. So the representation will gonna be like this. So let's jump into the point sampling. We're finally gonna produce jagged edges. So let's jump into our next method, which is a map map. Map map is used as a level of detail for texture and material. It is used for increasing or decreasing the texture quality to speed up the rendering time and reduce the stress of GPU and also CPU. Bitmaps is used in games development for optimizing the game and have a good quality texture. Bitmaps consist of multiple same textures with different resolution, and we can see here it is an identical kind of images but different kind of resolution. So here is a comparison with using mip mapping and also without a mip map. So as we can see here, without a mip map we can see a lot of square that were rendered. Without a mip mapping, all of the square will be rendered, and this will put a stress inside a GPU and CPU. So let's go to our last method of 3D texture mapping, which is sum aerial tables. Some area tables is similarly to mip mapping but produce less blurry texture. And how this SAT is processing the data is actually they generating the sum of values in a rectangular subset of a grid. SAT will keep sum of everything below and to the left of the texture for smooth color transition between pixel color. However, it required additional memory to hold the four values as shown at the example below for finding the upper right corner texture color. So that's all my explanation for texture mapping, and now I'm gonna pass it into the Faris Farhan. Thank you.
Assalamualaikum. My name is Faris Farhan and I'm going to continue presenting about the comparison between the three methods mentioned by Aiman, which are point sampling, map, and sum area table. In terms of quality, point sampling is not good because it will produce jagged edges. Map will overcome the jagged edges, but it will produce overblurring, and some area table will produce less blurry than map. So this is the best in terms of quality. For the memory, one sampling uses less memory, map uses medium, and some area table use more than both of the others. In terms of rendering, point sampling is slow. Some area table is faster, but map is the faster among all. So this is pretty much the same as previously mentioned. Jagged edges will produce the point can be prevented by using the average color. This can also be said as map with calculating the average color, and map will produce over blurry effect. The sum area table produce less blurry texture than map, but it will require high computational time. So this is the visualization. See, as you can see, point sampling will produce jagged lines. Map mapping will produce over blurring, but no jagged line is smooth. Some area table is the best. No jagged lines and no overblurring. Now let's move on to the implementation. So this is the basic implementation of texture mapping. So this is UV canvas. So on a normal canvas, we project the image, which is a texture, on the UV canvas, and then we we put a cube mesh on top of the UV canvas, and then we unwrap it like a box. Then we project the texture onto the mesh. Then we remove the extra part, unnecessary part, the outer part here. And then we wrap the mesh back to the original form, and there we go. We produce a texture mesh. So we can also implement it with other shapes such as cylinder and sphere. However, there will be different difficulties in doing that, because sphere is more complex and cylinder is more uh, not well, it's not complex. It's more easier than the cube. So conclusion is it's different for every object. Excuse me. Okay, so I think that's all from our group. Thank you for listening and watching. Assalamualaikum warahmatullahi wabarakatuh.